November 2024, an Antarctic research station receives a warning: winds over 100 miles per hour. Temperatures below minus 60 degrees Celsius and visibility near zero.
That's new.
They have 48 hours to prepare for a total lockdown. When stepping outside for seconds can kill. No rescue, no evacuation. The nearest civilization is 600 miles away, and the sun won't rise for 2 more months. 50 people will be sealed inside a few structures for days as hurricane winds and deep cold pound the walls. How do you keep systems running? Move between buildings you can't see? Stay sane after months of darkness? What if someone goes missing? Or a fire erupts and the only escape is into the storm? This is life under Condition 1, where survival depends on engineering, protocol, and discipline against the most violent weather on Earth. Before the storm, an Antarctic station operates like a small industrial town. Scientists run experiments on ice cores and atmospheric samples. Technicians maintain diesel generators that provide all electrical power. The water system operator runs the snowmelt tanks that turn collected snow into fresh water. The galley serves breakfast at 7 a.m., lunch at noon, dinner at 6 p.m. every single day. People move freely between buildings, walking from the dormitory to the lab, from the garage to the communication center, sometimes in nothing more than a fleece jacket because it's a relatively mild 30 degrees Celsius outside. The station's weather classification sits at Condition 3, which means normal. All outdoor travel is permitted. All work continues as scheduled, but everyone on the station knows this baseline is temporary. Katabatic winds, gravity-driven air masses that flow down from Antarctica's interior plateau, can accelerate from calm to over 100 miles per hour in a matter of hours. The transition from normal operations to total lockdown must happen in under 48 hours, or people die. This isn't theoretical. The procedures exist because someone, at some point, didn't follow them and paid the price. Every hand rope strung between buildings, every backup generator, every emergency food cache. These are lessons written in frostbite and hypothermia. The weather forecast arrives via satellite. A low-pressure system is moving across the continental interior, and the models predict it will reach the station in approximately 40 hours. Projected wind speeds, 100 to 120 miles per hour. Projected temperature, minus 62 degrees Celsius. Projected visibility, less than 100 feet. The station manager reviews the data and makes the call. The station transitions from Condition 3 to Condition 2, warning status. This is not a suggestion. Condition 2 activates a station-wide protocol known as battening down, a choreographed checklist designed to answer a single question: can we lock ourselves inside these buildings for 7 days and survive? The first priority is securing all outdoor materials. Anything left unsecured becomes a projectile in 100-mile-per-hour winds. Field teams bring in scientific equipment, weather stations, sample crates, toolkits. The logistics crew lashes down shipping containers with heavy-duty chains and parks all vehicles either inside heated garages or in leaguers, tight clusters where the machines shield each other from the wind. Empty pallets, spare lumber, and anything that can move get brought indoors or tied to fixed structures. Next comes the life support top-off. The powerhouse team fills fuel tanks and tests all generators. The water operator tops off the snowmelt system. Going outside to collect more during Condition 1 is impossible, so the tanks must hold enough for 50 people for at least a week. The galley stocks its freezers in dry storage, calculating meals with a buffer for delays. Communications, heating vents, and medical supplies all receive final checks. Finally, a full personnel headcount is taken. Every single person on the station must be accounted for and assigned to a specific building before Condition 1 is declared. No exceptions. The station is transforming from a work site into a sealed fortress, and the clock is ticking. The threat isn't one thing. It's 3 simultaneous failures happening at once. The first is the wind. These are katabatic winds, a gravity-driven phenomenon where cold, dense air from the interior plateau, sitting at over 10,000 feet elevation, is pulled down slope by gravity toward the coast. As this air mass funnels through valleys and accelerates over ice shelves, it can reach sustained speeds of 150 to 200 miles per hour at coastal stations like Mawson and Dumont d'Urville. This wind pushes like a physical wall. The air is so cold and dense that it carries extraordinary force, and it picks up loose snow and ice crystals, turning the atmosphere into a horizontal sandblaster. The sound is a constant, high-pitched shriek, like standing next to a jet engine, that penetrates even the most insulated walls. The second is the cold. Ambient thermometer readings can drop below 60 degrees Celsius. The coldest temperature ever recorded on Earth, minus 89.2 degrees Celsius, was measured at Vostok Station, but wind chill measures the rate of heat loss from exposed skin, and at minus 60 degrees, with 100-mile-per-hour winds, any exposed skin begins to freeze in under 30 seconds. The skin turns white and waxy. Frostbite sets in before the person feels pain because the nerve endings freeze first. A gap between goggles and a balaclava, a wrist exposed while adjusting a glove. That's all it takes. The cold also makes materials brittle. Metal can snap. Rubber and plastic shatter like glass. Diesel fuel thickens into gel. The third is the whiteout. When the wind picks up enough blowing snow, the air becomes indistinguishable from the ground and the overcast sky. The result is total sensory deprivation. No horizon, no shadows, no depth perception. The world becomes a uniform, glowing white void. People describe it as living inside a ping pong ball. You cannot tell if you're walking uphill, downhill, or in a circle. People have become hopelessly lost just 10 meters from the door of a massive building. Your vestibular system, the inner ear mechanism that tells you which way is up, stops working because there are no visual cues to confirm balance. Crawling on hands and knees becomes the only way to move, and even then, you can lose your sense of direction in seconds. The station's architecture reflects a single principle: avoid the fight. Modern Antarctic stations are not built to resist the wind. They're built to let it pass harmlessly. The structures use aerodynamic profiles, rounded edges, sloped walls, smooth surfaces designed like aircraft wings. When wind hits a curved surface at an angle, it accelerates over and around the structure instead of slamming into a flat wall. This minimizes pressure differentials that could rip panels off or compromise structural integrity. Halley 6, Britain's Antarctic research station, sits on the Brunt ice shelf. The entire station is elevated 15 to 20 feet above the ice on giant hydraulic legs. Wind accelerates underneath the structure, scouring away snow and preventing drifts from forming. As annual snowfall accumulates, about 3 feet per year, the station's legs are individually raised in sections, allowing it to climb out of the burial. Halley 6 is also modular and built on enormous skis, so if the ice shelf begins to fracture, tractors can tow the entire station to a new location. Germany's Neumayer 3 uses the same principle: hydraulic jacks, aerodynamic design, elevation above the ice. The goal is not strength. The goal is to deny the environment the opportunity to destroy you. The Amundsen-Scott South Pole Station uses a different solution. It sits on stable compacted ice at 9,300 feet, where the ice sheet is over 2 miles thick. The main structure is a massive elevated wing, angled into the prevailing wind. The supports are thin and widely spaced, creating wind tunnel channels that accelerate airflow between buildings. This scouring effect keeps pathways clear and prevents snow from accumulating in critical areas. Windows are a failure point. They're small, triple-glazed, and recessed deep into the walls. On the windward side of buildings, windows may not exist at all, or they're protected by heavy storm shutters that can be sealed from the inside. Every entrance is an Arctic porch, a 2-door airlock system. You open the outer door, step into a small, unheated vestibule, and close the outer door behind you. Only then do you open the inner door to the heated interior. This prevents the storm from exploding into the living quarters when someone enters. Closing the outer door during Condition 1 can require your full body weight because the wind is trying to rip it off its hinges. For stations like McMurdo and the South Pole, critical infrastructure, power lines, water pipes, sewer lines, runs through utilidors, which are heated tunnels built under the ice or connecting buildings. During Condition 1, a technician can walk from the powerhouse to the main station through these tunnels to fix a broken pipe or cable without ever going outside. The station is not a collection of buildings. It's a single, interconnected organism designed to survive with zero external support for months at a time. The storm arrives on schedule. Wind speed crosses 100 miles per hour. Visibility drops below 100 feet. The station manager declares Condition 1, total lockdown. No one leaves their building, period. There are no exceptions for convenience or curiosity. The hand lines, heavy ropes strung on poles between essential structures, are still there, but using them requires direct go-no-go permission from the station manager, and that permission is never given for a solo trip. Condition 1 is governed by 3 absolute rules. Never go alone. Never go without a physical lifeline. Never go without radio check-ins on a precise schedule. If you must move between buildings, a generator failure, a medical emergency, you go as a team of at least 3 people. 1 person does the work. 1 person watches the worker for signs of frostbite or fumbling. 1 person watches the storm and maintains radio contact with the communication center. You clip your harness to the hand line with a carabiner, or at minimum, you maintain a hand-over-hand grip on the rope. Letting go for 5 seconds can be fatal. Historical records show people who released the rope to adjust a glove or wipe their goggles, then spent the next 20 minutes crawling in circles, searching for a line they were standing next to. Every movement is reported. Comms, this is SAR Alpha. We are departing the powerhouse on Line 2, heading to the Science Building. Estimated time en route, 3 minutes. Comms replies, copy, SAR Alpha. Report on arrival. If that 3-minute check-in is missed, the station's search and rescue team is put on standby. If the 5-minute mark passes with no contact, the SAR team suits up. The extreme cold weather kit seals every millimeter of skin. You wear a synthetic or merino wool base layer, never cotton because cotton absorbs sweat and then freezes. Over that, fleece mid-layers in a heavy down vest. The outer shell is the big red parka, a windproof Gore-Tex or canvas coat with a fur ruff around the hood. Airflow around your face, creating a small pocket of relatively warmer air to breathe and preventing the wind from directly scouring your skin. You wear a balaclava, neck gaiter, fleece hat, and parka hood simultaneously. Goggles create a seal around your eyes. Without them, the 100-mile-per-hour wind and ice crystals would sandblast your corneas, and your own breath moisture would freeze your eyelashes together instantly. Your hands use a 2-part system, thin liner gloves for dexterity, worn inside expedition-weight mittens. Your feet go into bunny boots, extreme cold vapor barrier boots with thick sealed insulation that trap all heat and moisture inside. The hidden skill is thermoregulation. If you dress in full gear and then work hard, digging, lifting, pulling, you will overheat. That sweat will soak your base layers. The moment you stop moving, that moisture will freeze, and you will become hypothermic inside your survival suit. The solution is to manage your layers before you start working. You unzip vents. You remove mid-layers. You move at a steady, deliberate pace, not a sprint. 15 people are now confined to a single building for 3 to 5 days. They've already been on station for 4 months without sunlight. Winter over syndrome is a documented phenomenon. Cognitive fog, difficulty concentrating, forgetfulness, slowed reaction times, emotional blunting, irritability, and sleep disruption. The 24-hour darkness already destroys the circadian rhythm. A blizzard adds noise, anxiety, and physical confinement. The station combats this with routine. People wake at their normal time. The galley serves breakfast at 7 a.m., lunch at noon, and dinner at 6 p.m. Teams report for duty, monitoring system readouts, conducting inventory, and cleaning workspaces. This structure prevents psychological drift. The cook is the lead morale officer. A good hot meal during a 3-day storm is operationally critical, tangible proof that the system is functioning. The station manager organizes movie marathons, chili cook-offs, and trivia tournaments. These are not optional activities. They're part of the protocol, because a station where people stop eating, stop talking, stop maintaining their routines is a station on the edge of failure. The social pressure is immense. Breaking Condition 1 rules means forcing the search and rescue team to risk their lives to find you. The station is a closed loop. Everyone depends on everyone else. There is no margin for individualism. 2 scenarios override. Condition 1, a lost person or a fire. If someone misses a radio check-in, the alarm goes out. The station's search and rescue team, an all-volunteer group that has trained for this exact scenario, is the only unit authorized to leave their building. They cannot just wander. The search follows a protocol. First, they sweep the hand lines, checking every meter of rope between buildings. If the person isn't clipped to the line, the team forms a human chain, roped together at 5-foot intervals, and conducts a grid search of the area. They use vehicle-mounted lights if a piston-bully tracked vehicle can be deployed safely. They carry thermal imaging cameras, but in a 100-mile-per-hour whiteout, these tools are of limited use. The search is primarily by feel, crawling, probing with ski poles, shouting into the wind, hoping for a response. It is the most dangerous job on the continent. Fire is the ultimate threat. The air in Antarctica is exceptionally dry. Humidity near zero, which means fire spreads with explosive speed. You cannot fight a fire from outside during a Condition 1 blizzard. And if you have to evacuate, you are running from flames into an environment that will kill you in minutes. Every station has a contingency. At the South Pole, it's called the Emergency Camp, a separate, smaller building located several hundred feet from the main station, stocked with its own food, fuel, generators, sleeping cots, and survival supplies for the entire winter-over crew. If the main station is lost to fire, the population must navigate the blizzard, following pre-established hand lines to this lifeboat shelter, where they will ride out both the storm and the rest of the winter. This is why fire drills are practiced with the same intensity as blizzard protocols. The crew rehearses donning full ECW gear, clipping to hand lines, and moving as a coordinated unit through simulated whiteout conditions. The evacuation route is memorized. The hand line path is checked and maintained weekly. Power loss is another catastrophic failure. Without power, there is no heat, no light, no water production, and no communications. The station goes dark and silent. Temperatures inside the buildings begin to drop within hours. Redundancy is the solution. Stations run multiple diesel generators in parallel. If one fails, a backup kicks in automatically. If the entire powerhouse is destroyed by fire, mechanical failure, or structural collapse, the emergency shelter has its own independent generator, fuel supply, and heating system. This creates a cold, dark, but survivable final layer of safety. Every system assumes the primary will fail. Every building assumes it might be cut off. Every person assumes they might be the one who has to fix the problem in the middle of the storm. This is not pessimism. This is survival. After 3 days, the wind begins to drop. The anemometer readings fall below 55 knots. Visibility improves to 200 feet, then 500 feet. The station transitions from Condition 1 back to Condition 2, then to Condition 3. Teams emerge and begin post-storm operations. Snowdrifts have buried some entrances. These must be excavated with shovels and plows before buildings can be accessed safely. Exterior equipment is dug out. Structural inspections check for wind damage, loose panels, compromised seals, broken fixtures. The hand lines are inspected for fraying or anchor point failure and retensioned. Vehicles buried in leaguers are cleared and restarted. Cold start procedures at -50 degrees require preheating engines with external heaters. The powerhouse team runs diagnostics on generators that have been running continuously under load for 72 hours. The water system operator checks the snowmelt tanks and resumes collection operations. The communications team verifies satellite uplinks and reports station status to the program headquarters. The galley restocks from deep storage. Scientists resume experiments. But the winter continues. The sun will not rise for another 2 months. The station will remain cut off from the outside world. No planes, no ships, no resupply for another 60 to 90 days. The next blizzard could arrive in a week. The system worked because it assumed failure at every level. It assumed people would make mistakes. It is assumed equipment would break. It assumed the environment would find every weakness. The hand lines exist because someone once let go of the rope. The emergency shelter exists because a fire will eventually start. The redundant generators exist because the primary will fail. 50 people survived because 50 people followed procedures designed by the people who didn't.